Good morning, geometry students. Okay, so last time we were together, we talked about three things, and hopefully you remember those three things. Those three things were, one, what a similarity ratio was. So let's review that. What in the world was a similarity ratio? And similarity ratio, and I'm going to abbreviate it, but a similarity ratio is just the ratio of what? Of two corresponding sides from two similar figures. Whew, extra sloppy today. Similar ratio is the ratio of two corresponding sides from two similar figures. That's a similarity ratio. So as I look at this top picture right here, if you had to tell me what in the world is a similarity ratio, well, as long as those are similar figures, which it says they are, then the similarity ratio is 4 to 5. Okay, so that's the first thing that we talked about. The second thing that we talked about was this idea of perimeter ratio. Now, perimeter ratio really almost got overlooked because why? Because the perimeter ratio is the similarity ratio. They're always the exact same number. So again, look at that number 1 right there. If I know the similarity ratio is 4 to 5, then the perimeter ratio is also 4 to 5. And so that one almost gets overlooked because it's so simple. All right. And then lastly, we talked about something called the area ratio, which is the ratio of the two areas. Now, you don't have to have the area of each figure to find it. You can. That's one of the ways. If you're given the two areas, well, then you can compare those two numbers, and you've got the area ratio. You can reduce it. But if I only have the similarity ratio, or I only have the perimeter ratio, and it wouldn't matter which because they're the same thing, then the area ratio is always the similarity ratio squared. Okay, no matter what it is, like in that case right there, 4 to 5 for number 1. So therefore the area ratio, I put 4 over 5 and then I square it. And I get 16 over 25. So these are the three big points. We said similarity ratio, man, that's just when you compare, it's the ratio of two corresponding sides from similar figures. The perimeter ratio, we said that's always the same as the similarity ratio. And the area ratio is just the similarity ratio squared. Okay? And so this was really simple. So as long as we knew those three concepts, then we could do any of this. Similarity ratio is always the ratio of two corresponding sides. The perimeter ratio is the same as the similarity ratio. And the area ratio is the similarity ratio squared. Okay, so we were able to do this real simple. Let's see if I can get rid of all this stuff. All right, there we go. And so anyway, this was a pretty simple task. Some of these problems got a little bit challenging, but that was just because all of a sudden we had to use it. And of course we should use it. It's new knowledge. Okay, so let's take a look at these problems right here, right in blue so it stands out. It says in the directions, for each pair of similar figures, find the ratio of the perimeters and the ratio of their areas. Okay, now please, if you don't have your homework out yet, please get it out. We are taking a quiz on this today. I want you to do your best. Okay, so number 1, we're looking for the ratio of the perimeters and the ratio of the areas. Okay, so for number 1, we know that the perimeter ratio, I'm going to abbreviate PR, is the same thing as the similarity ratio. So in this case, that is just 4 to 5. And we know the area ratio is just going to be the perimeter or similarity ratio squared. And so that's going to be 16 to 25. Done. Number 2. Okay, number 2 is a little bit tricky because it gives us multiple sides. And we got to make sure we're comparing corresponding sides. So I look at 5. 5 is adjacent to the angle with one arc, and so is 3. 3 is adjacent to the angle with one arc. And so those two angles correspond to each other. And so I could say this one is 3 to 5. So that is the perimeter ratio. I say the perimeter ratio is 3 to 5. The area ratio is always going to be the perimeter or similarity ratio squared. And so that gives me 9/25. Okay, and the last one, number 3. Again, make sure you're comparing like sides. Look at this side right here. That's 4. 4 is in between those two angles that I have information about. That would correspond to this side down here, which I don't know. But fortunately, I do know this other side. right here, the smallest side, 3, which is adjacent to that right angle, okay, and 4 is adjacent to that right angle. So those two sides correspond, okay? All right, so if that's the case, then I could say the perimeter ratio, which is the same as the similarity ratio, is just simply 3 to 4. And the area ratio is 3 to 4, or 3/4 squared. That's going to give me 9/16. Okay, so that's what you should have for the first 3. Let's move on. For the next 4 problems, all of these ask for the similarity ratio, but they give you the areas. So please understand, we're moving backwards on this one. We're given the areas, and from the areas, we can get the area ratio, but then we got to go back to get to the similarity ratio. So on number 4, I know that the area ratio, and again, I'm abbreviating that AR just in this video to save time. The area ratio is 8 to 32. And where did those numbers come from? Right here, 8 and 32. The inches squared would cancel out. Now, I'm always going to reduce if I can. And 8 over 32 reduces to 1 over 4. These two are still the same. 1/4 is still the area ratio. But then to find the similarity ratio, I have to take the square root of that. The square root of 1/4. Well, the square root of 1 is 1. The square root of 4 is 2. And so the similarity ratio for number 4 is 1/2. All right, let's try number 5. Number 5, the area ratio is from the information given. I get 81 and 25. So I say 81 over 25. That is the area ratio. The similarity ratio is going to be the square root of those two values, 81 over 25. Now that one didn't reduce. The other one, in number 4, it reduced, but this one does not. Square root of 81 is 9. The square root of 25 is 5. So the similarity ratio is 9/5. Okay, let's try number 6. Number 6, the information given is 10 and 360. So the area ratio is 10 over 360. Now that reduces. It's real easy to see that it reduces. You got a set of zeros that just cancel out. That doesn't work with any other number, but it works with zeros in a fraction. If something ends in a 0 on both the top and the bottom, you can cancel those out. But if they both end in a 2, you can't cancel those out. Okay? And so that gives me 1 over 36. So that is the area ratio. Then your job is to come up with the similarity ratio. The similarity ratio is then, of course, going to be the square root of 1 over 36. Square root of 1 is 1. Square root of 36 is 6. So the similarity ratio is 1/6. All right, home stretch. Number 7. Now we're talking about 2 circles. Now this might seem weird because we've just been doing, polygons and triangles, rectangles, all these different things. And so we might feel like circles aren't allowed. But circles are clearly similar to each other. And so because every circle is just like every other circle, it's just a different size. So that's kind of the definition of similarity when it comes to geometry. Okay, so I know that there are area ratios. And you might have freaked out because you saw pi. But you got to remember, the pi's would cancel out. Okay, so the area ratio is going to be 128 pi over 18 pi. Now, like I said, the pi's would cancel out. So you get 128 over 18. Now, I know more reduces than just that. They're both even numbers, if nothing else. So half of 128 is 64, and half of 18 is 9. Now, it doesn't reduce past that. So the similarity ratio is the square root of 64 over 9. Well, the square root of 64 is 8, and the square root of 9 is 3. Okay? So the similarity ratio is 8/3. All right. Moving on. Let's talk about 8, 9, and 10. These were the most challenging problems. Think about this. At the very beginning, you just had to know really those few statements, that this idea, the connection between perimeter ratio and area ratio, and that you had to square the perimeter similarity ratio to get to the area ratio. That was pretty simple. Okay. The next one, this was a little bit more challenging. We had to kind of go backwards by what I said. You were given some information about the area. You had to reduce it and then take the square root. Now these were the most challenging. These were where you had to use something. Okay. Notice what we're given. We're given the length of one side for each of these and the area of the smaller figure. Okay, so let's think about this. So for number 8, the first thing I do is I go, okay, I know that the similarity ratio is 12 to 5. And how do I know that? Because that's the ratio of two corresponding sides. But I'm asked to find the area of the larger figure. So the similarity ratio is not going to get me there. I have to find the area ratio, which is always going to be the similarity ratio squared. So that's going to be 144 over 25. I have the area of the smaller, it said that in the directions, I have the area of the smaller figure. So then I set up a proportion, and I say 144 is to 25 in the same way that x, because I don't know the larger one, is to 20. Now you can reduce this if you can rewrite this different ways, but worst case scenario, if you wrote this as it is and had to cross multiply, well then you're going to have a little bit of work, and that's still fine. 144 times 20 would give me 2,880 is equal to 25x. Now, even if you're not great at math, you should still be able to do this division. Even if you got to do it off on the side, say, well, how many times does 25 go into 2,880? Well, 25 goes into 28 one time, leaves me with 3, and then the 8 comes down. 25 goes into 38 one time, leaves me with 13, drop the 0. And 25 goes into 135 times, which is 125, leaves 5, drop another 0, but here's where the decimal would be. So it would go up there. And so then I would get 25 goes into 50 2 times. So my answer is 115.2. X is 115.2. And when I say X, I mean the area of the larger figure. The area of the smaller figure in that first one was 20. The area of the larger figure is 115.2. Okay, we got this. All right, number 9. First, start with that similarity ratio. And I'm telling you, it just works well to label everything that you have. Make sure you don't kind of lose track. Similarity ratio is 7 to 15. So therefore, what in the world is the area ratio? Well, it's going to be 7/15 squared, which is 49 over 225. 7 times 7 is 49. 15 times 15 is 225. The area ratio of the area of the smaller figure is 84. So I can say 84 is to x the same way that 49 is to 225. Now, again, we talked about how you can rewrite these. You know, you could kind of write this looking at it sideways this way, and you're welcome to rewrite it and say 84 is to the number that's across from 84, 49, in the same way that x is the number that's across from x, 225. The reason why I might want to do that is because both of these numbers are divisible by 7. So it just might make my job a little bit easier. 7 times 12 is 84. 7 times 7 is 49. And now all of a sudden I'm dealing with much smaller values. I mean, 225 is still pretty big, but this is a little bit nicer. So I say, well, that means that 7x is equal to, let's see, 225 times 12 is, what is that, an even 2,700. Okay, I think. Yeah, 200 times 12 is 2,400. 25 times 12 is 300. 24 and 300 is 2,700. And then you just divide. Now, that doesn't come out clean. So I'm actually completely okay with you leaving it as a decimal because 7 does not go into 2,700 evenly. So you can say x is equal to, or I'm okay with you leaving it as a fraction. X is equal to 2,700 over 7. All right? All right, so whether we got that one to reduce or not, we still didn't get very pretty values. All right, let's talk about number 10. Erase number 8 here. Okay. Should have tried a different way. There we go. Okay, so number 10. Number 10, what do we start with? We've got the similarity ratio. Similarity ratio is 5 to 8, so therefore the area ratio, we just take that and square it. We go 5 to 8 squared gives me 25 to 64. Okay, we got the area of the smaller one is 18. So we say 25 is to 64 in the same way that 18 is to some unknown. Let's cross multiply. That gives me 25x is equal to 64 times 18. Let's see. That's going to be a pretty big value. 1,280 minus 128. Golly, what is that? 1,152, I believe. Somebody check, see if I'm right. I think I'm right. All right, so then we'll divide both sides by 25, and x goes into there, let's see, about 44, 45, 46 times. 46, 0.08, I believe. I think 25 times 46.08 is giving me 1152. And so either way, area of the larger figure, because we said the area of the smaller figure was 18, so the area of the larger figure would be 46.08. All right, pretty simple stuff. This isn't super duper hard. I want to really recommend that you kind of follow this train of thought. Start with the similarity ratio, then move to the area ratio, set up your proportion, and then solve. I got a lot of people who are just kind of throwing down numbers, but if you track what you're doing, start here and move in a sequential pattern, you won't mess up. Sometimes people are in such a hurry that they just take this and plug it in down here, and then they get the wrong value here. But the best thing to do is just kind of think through the whole process. Okay, almost done. For these, it's asking us to find the ratio of the perimeter. So I hope you realize that this is really identical to these. 4, 5, 6, and 7 is the exact same type of problem as 11, 12, and 13. It's just they gave us pictures for 11, 12, and 13. So for number 11, I say, well, I know I've got 12 to 27. And like I said, it'd be good to kind of track what in the world that is. And that is the area ratio. How do I know? Because I literally compared the two areas. They're both divisible by 3, so I get 4 over 9. And so therefore, I say the similarity ratio is equal to the square root of 4 over 9. That's going to be 2/3. Number 12, the area ratio is 1 to 4. So therefore, the similarity ratio is going to be the square root of 1/4, or 1 to 4. Square root of 1 is 1. Square root of 4 is 2. And number 13, the area ratio is 8 to 50. So therefore, the similarity ratio is the square root of 8 to 50. But before I do that, I'm getting a little ahead of myself. 8 to 50, I don't know the square root of 8. I don't know the square root of 50. But if I look back up here, this reduces. And that reduces so that the area ratio is 4 over 25. So therefore, the similarity ratio is the square root of 4 over 25. Square root of 4 is 2. Square root of 25 is 5. Okay, last problem. Last problem, all words. You got to try to picture this and see what's going on. We did some just like this yesterday. We talked about octagons and triangles. This just like this. So it says the shorter sides of a rectangle are 6 feet. The shorter sides of a similar rectangle are 9 feet. Okay, I want to encourage you. You get a problem like this, draw it. Okay, so here's my smaller rectangle. Here's my little bit bigger rectangle. These are supposed to be similar. Mine sure don't look like it. So we're saying that this is 6 feet. This is 9 feet. The area of the smaller rectangle is 48. What is the area of the larger rectangle? That's what we're curious about. Well, so the first thing we do is we say, well, I know the similarity ratio is going to be 6 to 9, which reduces to 2/3. And so if the similarity ratio is 2/3, then the area ratio is just that value squared, 2/3 squared, which is going to give me 4/9. So that is the area ratio. If I'm looking to find area, I got to use the area ratio. So I say 4 is to 9 in the same way that, now which one do I have? The smaller rectangle is 48 square feet. So I got to compare it to the smaller one. And so then I cross multiply. This is the one I'm looking for. So I get that 4a is equal to 9 times 48 is what? 432. Divide that by 4, and you get 108 square feet. Okay? So the area of the larger rectangle is 108 square feet. All right, guys, I wish I was there to answer any remaining questions, but I think we've covered everything over and over and over and over and over. So what we're going to do right now is we're going to take a practice quiz, and then we're going to go over that quickly, and then you get a chance to take the real quiz. All right? Make sure you don't take forever on the practice quiz, because otherwise we're going to run out of time on the real thing. All right, good luck.